Welcome back, guys. Today we're going to show you how to set up some tool paths and your stock for this part that we did earlier. So let's get started. So now that we're in this design view, we're going to click on this drop down where it says design and change it to manufacture. This brings up our new set of tools along this toolbar, and the first thing that we'll have to do is set up a machine and our stock. So if we click on the setup icon, or you can right click here and go to new setup, this dialog pops up and we'll want to select a machine. Now you guys might have different machines available in your shop. I like to pick the VF3 because I'm actually experienced with this machine in particular. If you wanted to select a different machine, you can click on this Fusion library and select from anything in this milling. And there are a wide arrangement of machines that you can select. If you're not sure, then just pick the Autodesk generic 3-axis. Now I'm going to select my Haas VF3. Our setup is going to be a milling operation, and my orientation, I want to set this up so select Z-axis plane and X-axis. So now it gives me this blue option here, and I want to select this face here, and then my X-axis is on that wall. Now you can select lines as well, so this would be a Z and this would be an X. If you have them reversed, then you can always click this flip reverse or flip Z-axis. Now I want to select my origin. Now if I go to the front, the origin is at the top of the material. Now as a machinist, I'm used to setting the origin as 0 on the top of the model. So let's click on model box point, and now you can see it is in the center of the box or the model, right at the top face. Once you're done with that, let's click on the stock tab. In our mode, it says relative size and it's offsetting by a small amount. Now, I'm thinking what I can buy from the mill, what material can be cut and ready for us, rather than having some arbitrary numbers based on our model. So if I go to fixed sized box, I can define my actual width. So let's call that 5 inches because that was the 4.5 was the actual model width. And my depth will be 4 inches. My height can stay at 1.5, and I'm okay with that. So let's click OK. And if we orbit, we can see the part hidden within this material. So now if I click on my top view, or if you wanted to, you can click on the home view, which is an isometric. Gives you a little more view of a few more faces. So the first operation is generally facing. So up here, we can click on the drop down if we're not sure what these are. If you hover over the buttons, it tells you whether we're facing a 2D adaptive clearing or 2D contour. Now I want to face. I'm going to go into my tool, and if you don't have any tools set up, click on the Fusion 360 library. We can click on our face mill up here, and I'm just going to use this default 2-inch face mill here. Now it shows you the parameters of the diameter, shaft length, so that would be in back here, and you even have some default data. So this would be your cutting speeds and feeds for this specific cutter, and if you wanted to, you can create new presets. So let's say that this is 1018 steel. I would probably want to add a new cutting parameters. So let's select that for now. And these are all as default. I can go to custom. And if I'm doing 1018 steel, I'm usually running my surface speed at 800 surface feet per minute in 1018 for carbide. Now this automatically changes my spindle speed and my ramp spindle speed. My cutting feed rate, I usually go off the package of inserts that will tell me the optimal feed per tooth, or you can visit the manufacturer website. So I'm going to put in 10 thou feed per tooth. There's 4 teeth on this, so this gives me a feed rate of 76 inches a minute at an RPM of 1527. My lead-in feed rate can stay as default. My ramp feed rate can stay as 65. My plunge feed rate should always be lower, but we're going to be sitting outside of the part and then milling sideways, so that shouldn't be damaging to the cutter. If you wanted to change any of these values and keep them remaining as a default, you can always right-click in the field and then change the value and do Save as User Default. Another option would be if you wanted to make it a multiple of something, you could do the math with Edit Expression. So you can type in a variable, let's say diameter, and then times 0.6. And then if you hit OK, it will actually give you the math-based calculation on there. Okay, so I'm going to reset this as the system default. Now, I don't need any stock contours because we're plunging outside the material. And tool orientation is for multi-axis operations. So I'm going to go to my heights, and I want to select my bottom height as the model top. Okay, so it's already there. So that means when I go to my front view, I can see that my cutter will cut the top face and nothing more or nothing less. I like to have a retract height of 2 inches for clearance. Okay, this I've set as a default. So that allows me to save the cutter just in case my offsets might be incorrect. And this can happen at any time. So just give yourself a buffer before you start cutting, and then you can check your height. Now my passes, this is going to change based on some of our options here. Now I have a sharp corner on my tool, and my tolerance should remain at 4/10 of a thou. My pass direction is 0 degrees, which is always from left to right. So my pass extensions are going to extend the passes beyond the machining boundary. So if you hover over top of any of these options, it will give you a tooltip showing you what might happen with your options. So our stock offset specifies the distance the machining boundary extends beyond the stock boundary in both the X and Y. And I'm going to leave these at 0 for now. My step over, you want this to be as efficient as possible. So 1.9 with a sharp nose radius is 100 thou overlap. So that's decent, except not many insert cutters that I've seen have sharp corners. So this will also do the calculation for you even if you have a nose rad. So if I were to go back to my tool and edit this where it would be a more accurate representation of my in-shop tool, I can put on a nose radius. Let's say it's 0.0625. So 16 thou nose radius, accept, and I'll select it. And now my defaults have changed once again. So just be careful of that. But if I wanted to, I can edit this tool in my document. Okay? In your Fusion library, those are rigid. You won't be able to edit those tools. But if you have them in your document, you can add parameters. So if I wanted to create a new 1018 CRMS, cold rolled mild steel, well then I can set up my parameters here. So let's say 800 surface feet per minute, and I'm going to put this as a default, so that should be about the same. My cutting feed rate, I want to do 10 thou per tooth. Okay, that changes everything there. My ramp feed rate, I'm going to reset that to default. Your plunge feed rate, I like to have this much lower, about 5 inches a minute. Passes and linking, you can use a step down or step over as a default. We'll leave this unchecked, and you can specify what tool numbers. Okay, there's lots of data in here. We're going to leave the most part as a default. Now, if you're doing any multi-axis stuff, you might want to change your holder. For what we're doing, not a huge issue. We're keeping everything clean and clear. Shouldn't have any collisions. So click Accept, and when you select your tool, you can also click this preset. So now everything pops in as a default. So you can change those as you go. And so going back to our passes, now it calculates our step over based on our corner radius. And so it doesn't have that 1.9 anymore. I can do cutting in climb milling or conventional milling, or both ways. So this will do a zigzag across the face. And if you just hover over, it shows you the different options. I like to use both ways because it saves a lot of time. I will select multiple depths. I change my maximum step down to 100 thou, and then I set this as a user default. I also add a finishing step of about 10 thou, and I can lower my feed rate by even just clicking Edit Expression. Tool feed cutting divided by 2. If you want to, you can use even step downs. Stock to leave, we're going to leave it to 0 because we're going to cut this flat. And then we can go to our linking. And this is where most of the defaults are pretty good. If you're worried about collisions with tool clamping or work holding, then you might want to change this, as well as your heights, where that would be your clearance height. Your lead-in and transitions, these can be turned on or off. This is totally up to you. Now, a recommendation that I can make is change one setting, see what it does, then change another. So if I click on OK, this should generate my toolpath. And if I right-click on this operation, I can simulate it. And then down here, we can press our play button. If we wanted to, we can slow it down and then rewind it to the beginning of the toolpath, and then we can watch it play. And this is something that we might want to just verify that we're cutting all of the material off the top. You can check to see your machining time. This is going to take 1 minute based on our feeds and speeds, and it even shows you the actual distance that the tool will move. So at this point, I would probably save, and if you just click on the outside in the white area, you can clear out your toolpath. Now the next thing I want to do is probably cut this outer area. Now you have to be mindful of how you're clamping this in your machine. So you might be clamping somewhere around here, maybe by 1/4 inch or so, just enough to hold on to it and get most of the bulk off. As this is just a block of steel, we have to get all these features cut in here. So let's do a 2D adaptive clearing. That's also this button here. Now, you can select a longer end mill to do more machining. So if you wanted to do like a flat end mill, and then we select from our, let's say we have a 3/4 inch, and we can drag tools up, and they even come with some presets as well. So let's say that we're going to do some high carbon steel roughing. It even gives us a surface speed of 200 feet per minute, so we can manipulate this, or maybe even low carbon steel. But you can also create your own data based on your manufacturer tool specific information. Okay, so I'm just going to go back and select low carbon steel roughing. Now this tool is going to do the outside. So I'm going to select my bottom contour here. I'll click on my clearance heights, and now just keep in mind that this is also interfering, so this contour is going to be below your vise potentially. So I might want to offset this by at least 0.3. And as you can see that I've accidentally clicked the enter button, I can just right click on the toolpath and click edit. Now on passes, might be a good idea to change your optimal load. If you hover over that, that's going to be the distance between passes. So I'm going to change this to about 100 thou. You can choose to cut both ways. Our minimum cutting radius is 75 thou. We could use slot clearing, but we don't need to. We're on the outside of the part. We're going to continue climb milling. We're going to leave multiple depths. And then our stock to leave, we'll just leave 20 thou on the outside and 0 on the axial stock leave. So that'll be up and down. Radial would be side to side. So anywhere from this face and this face, it'll leave 20 thou on this surface and all the way around. Whereas axial stock is going to be vertically. Smoothing, you can play around with this, but just be aware that sometimes it can crash your CAM software. For Mastercam, if you set it too high, it will sit there and render until it crashes. So just be aware of that. Your feed optimization, this will allow you to reduce the feed rate on corners and accelerate. So on outer corners, it'll accelerate. On inside corners, it'll decelerate. So I'm just going to leave that off for now. And here we have our linking. So that we're once again doing full retraction. We're keeping these as defaults. Our maximum stay down would be, let's leave it at 5 inch. Okay, now this is the percentage of the tool, or the distance that it will rapid over to the next cut. If you lower this number, it will rapid over more. If you increase this number, it'll stay down. And these all pertain to that. Lift height, sometimes this might be good for having the tool not drag across the bottom surface, but in my experience, I've noticed that with older machines, they tend to struggle because there's too many movements, and then they start slowing down the cut. Our leads and transitions, this will be our little horizontal lines you can see there, and they arc into the cut. It's a nice gradual material engagement. And the same with the vertical, that just kind of arcs into its actual height. Might not be necessary for older machines, but you can always set this. This is by default selected. It shouldn't activate because we have a small amount of material on the outside and we have access to just engage it gradually. So let's click OK and see what happens. So as you can see here, it has not added a helix motion into the cut. And that's because we have accessibility. And down here where it has not cut, that is where our vise is sitting. We have about 50 thou clearance. We're going to grab on by 1/4 inch. So if we wanted to check it, we could go to Simulate, and we can see the tool path that it will take. And it also pre-renders your previous operation, which is really handy. It saves you a lot of time. Now, if I want to finish this size, then what I can do is select my tool. Let's just stick with the 3/4 inch flat, and we'll select our contour just as before. We will want to offset this by 0.3. So then our finish cut isn't going to dig into our vise jaws. We have left-hand compensation. We can change our compensation here. Now this is dependent on how you program, whether you specify the diameter of the tool in the controller itself. Your wear will calculate the distance that it needs to be on the side of the part, plus whatever you will set in your controller to offset just by a little bit to maintain your sizes. And inverse wear is just, instead of negative values, this uses positive values to get the same result. And then off would send the center of the tool down the center of the line. So in that case, we would damage our part and cut out our entire wall. So in this case, this example, I'll leave in computer. So this is our finishing pass, so we're just going to leave it as is, unchecked. You can do roughing passes, so it'll do step overs, multiple depths if you have a shallow cutter, maybe with inserts or possibly a high speed or high feed end mill. Stock to leave. Smoothing once again, and feed optimization. And then our linking. We're going to leave this as is. We'll leave this as is. We're not going to ramp, and we don't need to pre-drill. So let's render that and see what happens. It's always good to have your lead-in and lead-outs on the front face where you can see. If this is the back of the machine, that means it's the back of the part and you won't be able to see. So it's always good to see if you're not going to collide with anything, and if you have your tool in the right spot. So now that we've completed our 2D contour toolpath, let's save, and I will see you guys for the next part of this video, and we'll do the inside pocket of this part and do our hole milling and do our tapping and drilling. All right, see you guys next time.